In this project that studies fluid mechanics, we will use knowledge about Bernoulli's equation to get theoretical information about an experimental model. This equation relates the pressure, the flow speed, and the height for the flow of an ideal fluid. In this easy-to-use equation, P is the pressure, the Greek letter ρ is the fluid density, y is the height, and v is the speed. Taking this scheme as a base for the experiment, we can explain that we make the water from a tank flow through a hose at a certain height from the floor, called d. From this model, we can consider that the initial speed is equal to 0 and the second height is 0 too. Both pressures are cancelled because we're using the pressure of the environment, so we get this expression to obtain the final speed. From this analysis, we can obtain the seconds it takes to empty the tank, dividing the total volume of the tank with the product of the area of the tube and the final speed. The objectives are to use Bernoulli's equation to obtain an expression for the time to empty a tank, measure the time to empty a tank experimentally at 4 different heights, and compare calculated versus experimental timing results.
First, we start having a D. Well, we have to say that the D is the height from the floor until the level of the water that is in the fishbowl. And the first one, it was 1 meter, well, in total was 1.155 meters. The second one was 1.995 meters. The third one was 3.035 meters. And the last one was 3.80 meters. We get the area of the hose because it will be very important to get the time it takes to get empty the tank. First, we get the area that is 2.071 multiplied by 10 power minus 4 meters. Then we get the D. As I said before, the D is the height or the distance between the floor and the level of the water. We have to use this D to get the exit speed. As we explained in the introduction, the formula is the root square of 2 multiplied by the gravity and the D, that it will be changing because we use 4 different heights. Then we have the formula of the time it will take to get empty the fishbowl. This formula is the time, it's equal to the volume, the total volume of the fishbowl over the area of the hose multiplied by the exit speed. And if we use the units, it will be cubic meters over meter square multiplied by meters over seconds, so we get the seconds. To get the time, so then here we have the different time, the theory time. When we were meter, we get 3.5 seconds, and we get the velocity. Then we get the new velocity, and the time when we were at 1.84 meters was 2.77 seconds. When we were to 2.88 meters, we have 2.90 seconds, and at least 3.61 meters, we get 1.96 seconds. Then we're gonna compare this with the experimental part. we measure this with the high technology of a chronometer, and we get that in 1 meter we get 12 seconds, in 1 point meters we get 11 seconds, in 2.88 meters we get 10 seconds, and 3.61 meters we get 8 seconds. So actually it will be a huge difference between the experimental and the theory, and here are the difference. In the one was 8.45 seconds, in the two 8.35 seconds, in the third 7.1 seconds, and in the fourth 6.04 seconds. So it's a huge difference.
We can recommend to consider locations in which the tank can be positioned firmly, to take all the measures needed from the heights and the materials before starting the experiment, and get organized with the teammates when doing the experiment to measure time accurately.
Finally, it is concluded that the formula to determine the time in which the hose is empty does not take into consideration the arc of the hose and also like the length of this. On the other hand, we assume that the formula takes into consideration that the hose is directly connected of the lower part of the hose to fall in free fall, and that the time is like the theoretical one, since we do not agree with the experimental one. So we think that we have to figure out the new formula, because talking about the units we get seconds, but we don't even get close to the theoretical results.